Good morning all. Today I am explaining Cauchy General principle for convergence of a sequence. Theorem: a sequence is convergent sequence if and only if it is a Cauchy sequence. It is a necessary sufficient condition. If the sequence is convergent, that sequence must be a Cauchy sequence. If the sequence is a Cauchy sequence, that must be a convergent sequence. For proving of this theorem, we need some basic information, that is, what is convergent sequence, what is Cauchy sequence, what is bounded sequence, what is superior, supremum, infimum, greatest lower bound, least upper bound and lower bound. We require the following. What is convergent sequence? For each epsilon greater than 0, there exists a number capital N just for it is a number, not natural number, such that n greater than capital N implies mod Sn minus L less than epsilon. Mod Sn minus L less than epsilon. That L is called as a limit of the sequence, convergent sequence. The sequence is called as a converges to limit L. What is Cauchy sequence? For each epsilon greater than 0, there exist numbers m and n such that mn greater than capital N implies mod Sn minus Sm less than epsilon, means the difference of these two sequences is always less than epsilon. That sequence Sn is called as a Cauchy sequence. Already we proved in the last lecture every Cauchy sequence is bounded sequence, and also we proved in the last lecture every convergent sequence is a Cauchy sequence. A sequence Sn is convergent, limit inferior of Sn is equal to limit superior of Sn. So these condition is hold, that sequence is convergent sequence. This sequence is convergent, limit inferior of Sn is same as limit superior of Sn. Already we proved certain problems this condition. Now also we need some notations for proving of this theorem. That notations are UN. UN means infimum of Sn n greater than capital N. What is infimum definition? Greatest lower bound of a sequence Sn is called as a infimum of the sequence, that is denoted by UN. Suppose L is a lower bound of a sequence, smaller than L is also called as a lower bounds. Out of these all lower bounds, greatest number is called as a greatest lower bound. That number is denoted by infimum of the sequence. So that greatest lower bound is always greater than or equal to remaining all the lower bounds. Greatest lower bound is always greater than or equal to lower bounds of a sequence Sn. So Un is equal to infimum of Sn such that n greater than n, which is always greater than lower bound of a sequence Sn. Same scenario, I can write this one. Here infimum of a sequence Sn is denoted by Un. Supremum, similarly, Vn is equal to supremum of Sn such that n greater than capital N. Vn is equal to supremum means what? Suppose U is an upper bound. The bigger numbers of U is also called as an upper bounds of a sequence Sn. Out of these upper bounds, smallest one, least one is called as a supremum of that sequence. So that is called as a least upper bound, LUB. So it is least one, for that LUB is always less than or equal to upper bounds of a sequence Sn. Because of U is an upper bound, the bigger number of U is also called as upper bounds. For that, supremum is what? Least upper bound. Least upper bound is always less than or equal to upper bound of a sequence Sn. So Vn is a supremum, so which is always less than or equal to upper bound of a sequence Sn. And also infimum of Sn is always less than or equal to limit infimum of a sequence Sn. Whereas supremum of Sn is always greater than or equal to limit supremum of a sequence Sn. Infimum is both conditions are reverse. Infimum of Sn is always less than or equal to this one. Supremum is always greater than or equal to limit superior of a sequence Sn. These are the conditions already we have. And also more general form, limit superior of Sn is always greater than or equal to limit inferior of Sn. And also limit inferior of Sn is always less than or equal to limit superior of Sn. We can write like that. We need a lower bound and upper bound also. What is lower bound? L less than or equal to Sn, the number, real number L is called as a lower bound of a sequence Sn, and Sn is called as a bounded below sequence for every n belongs to n. So in that sequence Sn, we find a number L which is less than all the members of the sequence. That number L is called as a lower bound. The sequence is called as a bounded below sequence. In upper bound, there exists a real number U such that Sn less than or equal to U for every n belongs to n. Every member of the sequence is always either equal or less than certain number U. That number U is called upper bound of a sequence. Now, firstly, I am taking sequence Sn is convergent sequence. Sequence Sn is a convergent sequence. Then we are going to prove that that sequence is a Cauchy sequence. Suppose Sn be any sequence which is a convergent sequence. Firstly, suppose that the Sn is a convergent sequence. What we are going to prove? That sequence Sn is a Cauchy sequence. Yes, let epsilon greater than 0 be given. Now, already this sequence is what? Convergence. Every convergent sequence converges certain number L. For that, let the sequence Sn converges to a number L. By definition of convergent sequence, for each epsilon greater than 0, there exists a number capital N such that n greater than capital N implies mod Sn minus S less than epsilon by 2. This is the equation 1. Because of I used the definition of convergence. So this condition is holds for n greater than capital N. If I am taking m greater than capital N, what happens? Just replacing n by m. M greater than capital N, this implies mod Sm minus S less than epsilon by 2. This is equation 2. Now consider I am m comma n greater than n. So both small m and capital N, small m and small n is bigger than n. Now I am taking these two difference, mod Sn minus S. Mod Sn minus Sm. Now adding and subtract S. Add and subtract S here. So Sn minus S plus S minus Sm. Here added and subtracted. This is equal to, now I am taking this is one term, it is another term. So I used triangle inequality condition. Sn minus S one term, S minus Sm is another term. So triangle inequality is what? Mod A plus B less than or equal to mod A plus mod B. Mod Sn minus S plus modulus of S minus Sm. Triangle inequality is, what is triangle inequality? Mod of A plus B less than or equal to mod A plus mod B. It is triangle inequality. Then mod Sn minus S, mod Sn minus S, you see first condition, less than epsilon by 2. So mod Sm minus S is same as S minus Sm, both are same. Modulus of A minus B same as modulus of B minus A. For that, mod S minus Sm means Sm minus S is also less than epsilon by 2. Sum of these two is epsilon by 2 plus epsilon by 2 means epsilon. So for m comma n greater than capital N, mod Sn minus Sm less than epsilon. This is the condition for what? Cauchy sequence. Hence Sn is a Cauchy sequence. Thus every convergent sequence is a Cauchy sequence. Thus every convergent sequence is a Cauchy sequence. Now converse part. Conversely, suppose that Sn is a Cauchy sequence. We have a lemma. So Sn is bounded. Every Cauchy sequence is a bounded sequence. Already we proved this theorem. Sn is a Cauchy sequence. Every Cauchy sequence is a bounded sequence. Now to show that Sn is a convergent sequence. What is the converse part? Every Cauchy sequence is convergent. So Sn is Cauchy sequence. Now we are going to prove that this sequence is a convergent sequence. For that we use this theorem to show limit inferior of a Sn is equal to limit supremum of superior of Sn. Both inferior of a sequence Sn is same as the limit inferior, superior both are equal, in this case we say that the sequence is convergent sequence. Right? Suppose I am taking 1 by n, Sn is equal to 1 by n. What is the limit inferior, limit superior both are 0 because of only one limit. So limit inferior is 0, limit superior is 0, so that the sequence is convergent sequence. So for this scenario I can use same concept here to show limit inferior of Sn is equal to limit superior of Sn. For this we are going to prove limit inferior of Sn less than or equal to limit superior of Sn, limit inferior of Sn greater than or equal to limit superior of Sn. Now I am taking, let un is equal to infimum, vn is equal to supremum. As Sn is a Cauchy sequence, already we assume that Sn is a Cauchy sequence. Then for each epsilon greater than 0, there exists a number capital N such that mn greater than capital N mod Sn minus Sm less than epsilon. It's basic definition of a Cauchy sequence. Now I am removing this modulus by using mod x less than c. We know that mod x less than c means what? Mod x less than c minus c less than x less than plus c. For this scenario, minus epsilon less than Sn minus Sm less than epsilon for mn both are greater than capital N. Adding Sm on both sides, Sm minus epsilon, so Sn minus Sm plus Sm both will be cancelled, Sn less than Sm plus epsilon. Here I am adding Sm on both sides, Sm minus epsilon less than Sn minus Sm plus Sm plus Sm cancel, then we get this condition for mn greater than capital N. So Sn is, I am taking this what? Sn less than Sm plus epsilon for n greater than capital N. This is say equation 3. Now you observe here this condition. So Sn is less than this number, this Sm plus epsilon is a number. For that Sn less than L, Sn less than or equal to U, that number U is called as the upper bound of a sequence Sn. So Sn less than or equal to U. So this number U, this is called as a upper bound of a sequence Sn. So Sm plus epsilon is an upper bound of a sequence Sn for n greater than capital N. Now Vn. What is Vn? Supremum of a sequence Sn n greater than capital N. Already we discussed for notation of the sequence. Vn is equal to this one, supremum of Sn n greater than capital N. So what is the supremum? What is this? Already we derive a condition. Supremum of Sn is always less than or equal to upper bound. Supremum of Sn is always less than or equal to upper bound. Yeah, here. Supremum of Sn is always less than or equal to upper bound. That means Vn. Vn is always less than or equal to upper bound. For this scenario, what is the upper bound of the sequence? Sm plus epsilon. Therefore, supremum of Sn less than or equal to an upper bound. Upper bound of the sequence Sn is Sm plus epsilon. So that Vn less than or equal to Sm plus epsilon. So bring this side epsilon, or Vn minus epsilon is less than or equal to Sm, or just subtract epsilon on both sides. We get Vn minus epsilon less than or equal to Sm. So by using this condition, L less than or equal to Sm form, L less than or equal to Sm form, it is in the form of L less than or equal to Sm. That L is called lower bound of a sequence Sm. So this is the lower bound. So Vn minus epsilon is a lower bound of a sequence Sm such that m greater than capital N. This is the lower bound of Sm, but this is an upper bound of Sn sequence. Right, clear? So Vn minus epsilon is the lower bound of the sequence, so that lower bound is always less than or equal to infimum of Sm such that m greater than capital N. Already we discussed that lower bound LB is always less than or equal to greatest lower bound. Lower bound of a sequence is always less than or equal to greatest lower bound. It is lower bound is always less than or equal to greatest lower GLB. Already we use this condition. Lower bound of a sequence is always less than or equal to, this is lower bound of a sequence is always less than or equal to infimum of Sn such that n greater than capital N. By using this condition, un minus epsilon less than or equal to this one. This is nothing but what is this infimum of Sm such that m greater than n is denoted by un. It is un. Already notations is there. This is un notation. So un minus epsilon is less than un. Un minus epsilon is less than un. Adding epsilon on both sides, we get un less than or equal to un plus epsilon. Here you see un minus epsilon less than or equal to un. Un minus epsilon less than or equal to un. So adding this is Vn, sorry. This is Vn minus epsilon less than or equal to Un. Therefore, Vn is less than or equal to Un plus epsilon. This is the equation 4. Also, we know that limit superior of Sn is always less than or equal to supremum of the sequence Sn. Limit superior of Sn less than or equal to supremum of the sequence Sn n greater than capital N. Supremum of Sn n greater than capital N, from the above notation, it is denoted by Vn. So from the above equation 4, Vn is less than or equal to Un plus epsilon by equation 4. Vn is less than or equal to Un plus epsilon. Un means what? Infimum of Sn such that n greater than. By notation, Un means infimum of Sn n greater than capital N plus epsilon same. We have a rule, infimum of Sn n less than n greater than capital N is always less than or equal to limit infimum. Infimum of a sequence Sn is always less than or equal to limit infimum of a sequence Sn epsilon same as this. We have a result, infimum of Sn n greater than capital N is always, means infimum of a sequence is always less than or equal to limit infimum of a sequence Sn. This is their rule. By using this rule, since epsilon is arbitrary, so epsilon goes to 0, which is smallest positive number, epsilon goes to 0, then limit supreme of Sn less than or equal to limit infimum of Sn, epsilon is equal to. Since epsilon is arbitrary, epsilon tends to 0, then by above inequality becomes limit superior of Sn is less than or equal to limit inferior of Sn. Just I am taking plus epsilon means it is 0, so this condition is holds. So limit superior of Sn is always less than or equal to limit inferior of Sn, equation 5. Also we know that every limit superior of Sn is always less than or equal to limit inferior of Sn. It is well known result, already we proved in the sequence. So limit superior of Sn is always greater than or equal to limit inferior of a sequence Sn. It is equation 6. From 5 and 6, it is, you observe here, both left hand side limit superior, right hand side is limit inferior. This is less than or equal to, this is less than greater than or equal to. So A is less than or equal to B, A is greater than or equal to B, then we say that A is equal to B. In the same scenario, limit superior of Sn is equal to limit inferior of a sequence Sn. It is less than or equal to, it is greater than or equal to, that means both are equal. So that limit inferior of Sn is equal to limit superior of Sn, then we say that Sn is a convergence. Already this is a theorem. So every Cauchy sequence is convergent sequence. So Sn is convergent. So already we proved every Cauchy sequence is a convergent sequence. Hence a sequence Sn is convergent, it must be a Cauchy sequence. If it is a Cauchy sequence, then that sequence must be a convergent sequence. This is the Cauchy general principle for convergence of a sequence. This is the important theorem in real analysis and part of Cauchy sequence. Thank you for watching this video. Thank you very much.